Now if we have two or more application tier services, the question now becomes, how will the end client connect? Will they go to machine 1 or will they go to machine 2? Well, they will go to either. But that means that the routing of the incoming calls from the client to the app tier will be done through something called LBR, load balancer. There are companies like Big IP, F5, they offer a Big IP, Cisco routers, Cisco, and there can be other hundreds of companies doing the same thing. There's a RAD view, load balancer. So the point is, the clients will now not connect to the app server. They will connect to the load balancer, and the load balancer is going to take the incoming HTTP protocol request, and it knows based on the URL that this request is for which machine, which server, software server, on what port. So I say, okay, go to machine 1 and contact form server on port 9000. This is how the URL will be translated for the client for making a connection to the form server. But now this connection is not going to go to machine 1, it is going to go to the load balancer. The load balancer will then see, based on how it is configured, where the request has to go, to machine 1 or machine 2, app server 1 or app server 2. So that way, if the machine 1 goes down, the surviving app server has all the same software services, and the clients can still connect and get serviced. They can still run the form, still run the report, still get their HTML documents, run CGI scripts and whatnot. So what happens to the database tier then? Well, if apps tier 1 goes down, we have apps tier 2, we have apps tier second machine, which can still make the database calls to the same database tier. So this is how we protect the apps tier software services. Now what happens if my database tier goes down? Well, since we have a single machine running the database instance, we will not be able to communicate and get the data back for any of the apps tier services. So what we do then? Well, this is where the RAC is going to come into picture and protect our data set. So now in this diagram which we are showing here on the left side, there are two nodes which have gone red. They have crashed. If our database is somehow protected, that means if I have the database accessible from various machines, if a couple of my machine goes down, I can still access my data files. The data is sitting in those shared database files, as the diagram shows. So now let's go to the next slide and discuss much more in detail. So this is a typical architecture for a protected Oracle deployed architecture. We have multiple application tiers. They are all protected. We have now, in this example, two database machines. Each of these machines, they are running the database instance, and all the data files are stored in a shared storage. So it doesn't matter if you are connecting from database machine 1 or database machine 2, you will get the same data set. To make this architecture work, the first and foremost thing we need to learn about is the shared storage. Now, the shared storage is typically a SAN storage. To get to the SAN from your database machines, you need to extend your I/O bus, because you're taking your I/O from the local host drives and deploying it externally. So you have to extend your I/O bus. That is done through a HBA, host bus adapter. and here the fabric switch is where it gets connected. It's a fiber channel and it goes to the SAN. Between the two nodes, we also show a private interconnect. This is typically a 1 gigabit switch. This is used for a technology called cache fusion. For the end user, in our example, the form server or Apache web server, if each database machine has 5 gig RAM, it will see as a 10 gig RAM. It will see as a unified working environment. So if machine 1 goes down, what is going to crash? Only the instance will crash. The database is still mounted on machine 2. So this is a typical RAC architecture. Now here, if an organization is going to deploy this kind of architecture, you are protected in all tiers. Your app tier is protected, your database tier is also protected. High-speed cluster interconnect is one of the key component for making RAC work. Shared storage, as I said again, is also a key component required for RAC. Let us now dig deeper. App tier protection is very easy as we saw it, but to protect your, we have a different seminar series just to distract for a second, which is going to talk about clustering the middle tier. If you're using 10G AS components, you can cluster your J2EE, you can cluster your web cache, you can also have a failover for your farm server and report server. You can do various ways. You can cluster your OID services, your LDAP services. So what I discussed earlier with you in terms of apps tier, this is the way typically it is done in terms of e-business suite deployments or a custom deployment. But if you are using 10G AS for J2E components and whatnot, there are other caching and clustering options available for middle tier. So let us now discuss, go and get back to RAC, which we are going to be focusing on in this presentation. Now these are the various Oracle RAC architecture components. We have low latency interconnect switch, which is going to be used for doing a block transfer between memory to memory. If you remember Oracle Parallel Server, when Oracle has to transfer a block from machine 1 to machine 2, it will make an IO call. It will write the block to the disk, and the machine 2 is going to go and read the block from the disk and get it in memory. It was creating a lot of IO contention issues. So typically in Oracle Parallel Server, you will use raw devices to eliminate all the OS buffers and all these things to make IO go a little faster. So now in 10G and 9i onwards, when Oracle came with the RAC, Real Application Cluster technology, they went away from writing the blocks from memory to disk, from disk to memory, memory to disk, disk to memory. When they are being transferred from machine 1 to machine 2 and all these things, they introduced something called cache fusion technology based on block transfer from memory to memory through a low latency interconnect switch, which can be typically a 1 gigabyte switch. It is a simple dedicated network between all these machines. So each machine will have a specific network card, a gigabit network card. It can be 1 gigabit or 10 gigabit. Typically most of the clients use 1 gigabit unless there's a need to go beyond that. So that will take care of the cache fusion technology, and you have a shared cache and you have memory to memory block transfers. Other part of